So today my group mate will be discuss this STA108 paperwork, which is the title to determine the acceleration by using simple pendulum. So chapter 1, Introduction. The objective of this study is to determine the acceleration by using a simple pendulum. For the significance of study, the study of acceleration through the use of a simple pendulum holds significant importance in the field of physics and beyond. A simple pendulum consists of a mass attracted to a string or rod, allowing it to swing back and forth under the force of gravity. To understanding acceleration in this context enable us to analyze and describe various physical phenomena, ranging from the behavior of pendulum clock to the motion of celestial bodies. For the limitation of study, one limitation in this experiment is the assumption of idealized condition. The analysis of a simple pendulum assumes negligible air resistance, friction, and other external factors that can affect its motion.
Okay, next, chapter 2, which is the methodology. For data description, so this study is show how its acceleration works, and it was conducted using a simple pendulum that is provided in our scientific physics lab manual. So the data obtained consists of the length of thread, which is 0.1 meter to 0.8 meter, and the time taken for 10 swings to complete by using digital stopwatch. So this experiment done accordingly to the lab procedure shown in the lab manual. So tabulation of data was one of the graphical techniques that used in this experiment. So based on the length of the thread and the amount time of the 10 swings to complete, so the result was recorded in a table. So in this study, we were using scattered plot diagram from the data that we got from the table first. And the thread's length is on the y-axis, while the amount of time taken for the 10 swings to complete is on the x-axis. So the scatter plot is used to show how the relationship of these two variables. So next we got the Duberl technique. So in this study, the values of means, median mode, standard deviation, variance, skewness, range, minimum, maximum, the first quartile and the third quartile have to be included. This will be shown in the next chapter, which will be presented by my friend Alicia. So by using correlation analysis, we can see how much closely related these two data are. So the strength of the positive or negative correlation between the data gained from the study of the time needed for the 10 swings to complete, which is t in second, and the thread's length, which is in meter, will be determined by the correlation coefficient values. So regression is also a straightforward linear relationship with just two variables, which is dependent variable y and independent variable x. It is impossible to modify or manipulate the dependent variable in regression analysis. Furthermore, it will help determining the nature of the link between these two variables. So we were using a simple linear regression equation, which is y equal to a plus bx, where x is independent variable, y is dependent variables, a is the y-intercept, and b is slope of the line.
To continue with this video, I will talk about the results and interpretation from what we have researched about. So firstly, as you can see, this is our tabular data for our experiment. Meanwhile, this is the scatter diagram that we have made from the table that we have shown before, and also the descriptive statistic analysis where we found by using the application IBM SPSS. From the analysis, we were able to measure the central tendency, which is the mean, which also means average, the mode, which is the highest frequency, and also the median, which is the value in the middle of the data set. For the mean, we have found that the mean for the length is 0.5. So it means that the average length used in this experiment is 0.5 meters. Meanwhile, for the mean of the period of oscillation is 13.413. So that means that the average period of oscillation in this experiment is 13.413 seconds. For the mode, which is the highest frequency, from the data, there were multiple modes that exist for both length and period oscillations, for which the mode for length is 0.10 and 7.3 for period of oscillation. Meanwhile, for the median, which is the value in the middle of the data set, the median for length is 0.5, where it means that the middle value of length in this experiment is 0.545 meters. Meanwhile, for period of oscillation, it is 13.795. So that means the middle value for period of oscillation in this experiment is 13.795. Meanwhile, for the measure of position, we have found that the first quartile, which is the 25th percentile from the analysis, it has the value of 0.225 meters for length and 9.813 seconds for period of oscillation. Meanwhile, for the second quartile is the 50th percentile, with the value of 0.45 meters for length and 13.795 seconds for period of oscillation, which also has the same values as the median. Meanwhile, for the third quartile is the 75th percentile, which has the value of 0.675 meters for length and 17.008 seconds for period of oscillation. We were also able to find the statistical dispersion, for example, the variance and also the standard deviation. For the variance of length, it is 0.06, which shows that the data set are relatively close to the mean with a small amount of variability or spread around it. In this case, the standard deviation is 0.2449, and since the standard deviation is relatively small, it suggests that the values in the data set are closely clustered around the mean of 0.5. In summary, the data set has relatively low dispersion with values that are tightly grouped around the mean. Meanwhile, the variance for the period of oscillation is 15.407, which shows that the data set are more spread out and more dispersed around the mean compared to the previous example, which is length. In this case, the standard deviation is 3.925, and since the standard deviation is relatively large, it suggests that the values in the dataset are more widely dispersed or scattered around the mean of 13.413. To summarize, the dataset has a higher level of dispersion compared to the previous example, which is length, as the values are more spread out around the mean, indicating a greater variability or inconsistency in the data. Meanwhile, we were also able to find out about the skewness, which is for length and period of oscillation is 0 and negative 0.327 respectively. The skewness value of 0 indicates that the distribution is perfectly symmetrical, meaning it has a balanced shape with no skew to the left or right. And this implies that the mean, median, and mode of the distribution are all equal. On the other hand, a skewness value of negative 0.327 suggests a slight negative skew. This indicates that the tail of the distribution is skewed towards the left side. This would mean that the mean would be less than the median, and the majority of the data points are concentrated towards the right side of the distribution. For the correlation, we were able to identify the strength of a linear relationship between the two variables, and from the graph, we can see that the pattern of their intersecting points can graphically show that the relationship patterns shows a strong positive correlation. As the table suggests, The Pearson's product moment correlation for length and period of oscillation correlated to each other with the value of 0.994. This value signifies a perfect and positive relationship between them. Meanwhile, we were also able to identify the regression using the coefficient of determination. So from the model summary table, we can see that the coefficient of determination value is between 0.989. This means that 98.9% of total variation in the regression equation can explain the model fits in the data very well, capturing a large portion of the variation. This high value suggests that the model is able to provide a highly accurate prediction or explanation of the period of oscillation, which is the dependent variable, by using the length, which is the independent variable.
So in conclusion, based on the data we have interpreted, we can conclude that as the length of the string increase, the period of oscillation also increase. As shown in the table at chapter 3, as the length of the string increase, the T also increases. This shows that this experiment or simple harmonic motion is in accordance with Galileo equation, which is from the physics formula. That's all from us. So thank you.